With the segment construction, the tunnel is secured by the first ring closure directly after the excavation. The lifting plate works with a vacuum. The experienced teams build a complete segment ring in about 25 minutes. The segments are produced in Marty's own factory. High-strength steel fiber concrete also makes the edge areas of the segment rings extremely rigid outside the reinforcement. The filled formwork passes through a 55-degree furnace. For the 7 segments of a segment ring, there are also 7 forms in the rotation. The segment rings are uniconical and allow for different curves of the tunnel in 13 installation positions. The curve development of the tunnel is determined by the order of delivery already in the segment plant. Meanwhile, the machine continues to drill. The complete dedusting of the air directly behind the cutter head is essential for work in the tunnel. The excavated material is transported away from the tunnel at the end of the machine. Since the machine moves, the belt is continuously extended and suspended from the tunnel vault. Because of the great risk of swelling of the rock, Marty builds an additional solid inner vault in the tunnel after the first excavation protection by using segments. In doing so, the supply and disposal of the tunnel boring machine must not be interrupted. The installation of the Renasco sealing membrane in the lower tunnel area is begun. The membrane is extremely weather and pressure resistant. It is only because of this membrane that the tunnel becomes truly waterproof. After sealing, the tunnel ground can be concreted. Because of the access to the tunnel boring machine, work is carried out under the drive-over bridge. The formwork for the concrete work hangs movable under the bridge. It is inserted into the area concreted the previous day. The formwork is extremely variable because the project requires walls with and without reinforcing iron and different wall thicknesses. The concrete is introduced by a concrete pump. Every day, a 10-meter formwork is concreted. Marty produces the concrete in a mobile concrete plant on site. The reinforcement cages for the next concrete stage are installed in parallel in front of the formwork. The extremely heavy cages are difficult to tow under the bridge. The supply traffic for the tunnel boring machine continues to run over the bridge. Once a day, when the ground concrete is dried, the entire bridge with the formwork advances by a 10-meter stage. Then the formwork is prepared under the bridge for the next concreting. On the bridge, the path from and to the tunnel boring machine is cleared again. This is an especially pleasant sight at lunch breaks. Now the service gallery is extended to the bridge. The lateral gaps are filled with excavation material. Thus, the tunnel floor in the shell construction is done. The vault is now cleared for the expansion of the upper tunnel area. The tunnel ventilation runs via the service gallery and the ventilating air conduits suspended on the vault. The air conduit is periodically moved, shown here only schematically. The conveyor belt, which is also suspended from the tunnel vault, is deposited on the tunnel ground by the belt transfer truck in a flat curve, which does not impede the operation of the belt. Now the vault is free and can be strengthened. As with the ground, work starts on the ceiling. First, sheeting is adhered to the segments with hot glue. Then the sheets are welded to each other by means of hot air fans. Each seam is made up of 2 directly adjacent welding lines. The seam can only pass quality control if no air escapes from the space between the sheets during the compressed air test. Now the tunnel is ready for the installation of the inner vault. First, the reinforcing cages are moved. The reinforcing vehicle moves the cages with precision into position and affixes them with its swivel arms. All the locations for the subsequent work can be easily reached via the moving work platforms. A good 50% of the tunnel that is located in the swell-capable gypsum Kuiper is reinforced. 10 meters per day would not be possible without prefabricated reinforcement cages. Only the last gap in the ridge area of the tunnel has to be manually reinforced. Then the vault can be concreted. The arched framework runs through the tunnel folded up. It is very mobile and can be retrofitted to different wall thicknesses. The elements of the head formwork are folded into gaps in the reinforcement and extruded as far as the segments. The elements are connected with sealing pieces and sealed against the segments with a compressed air hose. The concrete spreader runs in the formwork. The formwork is evenly filled via the mobile distribution station with swivel-type conveyor lines. The formwork has to carry up to 400 tons of liquid concrete and is extremely massive. The heavy-duty formwork is adjusted precisely down to the nearest millimeter. Then the concrete flows again. The functionality of the formwork allows for a concreting stage every 24 hours. To ensure that the pressure of the liquid concrete does not shift the formwork, the concrete is concreted symmetrically on both sides. A comparison with the segments shows the tremendous strength of the inner vault. That is why thermal insulation prevents the massive concrete from cooling too quickly and cracking. Finally, the intermediate ceiling is concreted. The area above the ceiling later serves as a smoke outlet in the event of fire. The concrete is supported by solid formwork tables until complete curing occurs. The last table in each case is folded together and transported to the next concreting stage under the other tables by a transport cart. After completion of the intermediate ceiling, the tunnel area in the shell is complete. With the tables of the intermediate ceiling, the vault formwork, the reinforcing, the hot melt and the conveyor belt vehicle and the bridge, Marti has created a complex choreography of special equipment which enables the tunnel to be built directly behind the tunnel boring machine. The good interplay of the equipment is no coincidence, as Marti Technik has planned and built all the equipment in its own plant in Moosseedorf. A long-standing experienced designer team and the close cooperation with the equally experienced metal construction workshop guarantee high-quality products. The complex control systems of the devices were also developed by Marti, realized in their own electrical workshop and finally delivered to the construction site together with the system components built in the factory. Here, using